All right, get out of it.
Yeah, get out of it. So I have it not following.
Oh, yeah.
Yeah.
Here we are.
I don't even know where to stand. Looking for a new picture.
All right. Hello, hackers. We are here for a great day, the day that Connor attempts to become Dr. Nelson.
It's definitely on Twitch right now, right? Someone confirm.
Can someone confirm?
The day that I don't stream when I think it's streaming.
That would be hilarious.
What's Twitch? It's all about for the subs.
I'll get on the chat later for memes.
Okay, good.
Yeah.
Good.
All right. Perfect. All right.
Oh, after.
Exactly. So we're here to watch Connor attempt to become Dr. Nelson. Connor's journey has been long and fraught with peril. And there's an awesome amount of kind of PhD and PhD kind of lore that probably will become legend as you know times move on. But I think it's fair to say, and I think as we'll hear today, Connor in a very top-notch way for a top-notch PhD has changed the world. And I did that once in the CyberGrant Challenge. And afterwards, the reason I bring it up, not to brag, but the reason I bring it up is afterwards, when we didn't win the CyberGrant Challenge, we got third place, still pretty good. But the the program manager of the CyberGrant Challenge, Mike Walker, walked up to me and said, Jan, don't think that this is the last amazing thing you'll do. There'll be other amazing things. And that, when you do any sort of amazing thing, it's important to know that there's more coming. So, Connor, even if you don't win this defense, there'll be more amazing things you do. All right, let's welcome Connor.
All right. So the first thing we need to do is switch back to OBS and make it so we can actually share my screen. Nice. All right. Thank you, Jan, for the awesome introduction. Today, I'm going to be presenting my dissertation defense titled Hacking the Learning Curve, Effective Cybersecurity Education at Scale. So Jan mentioned a bunch of lore, and it turns out that a lot of this talk will have to do with that lore. So maybe a better title for this, except maybe a little less scientific, is Building the Pwn.college. Goes back to 2018. In 2018, I reached out to Jan on Slack and messaged him saying, hey, I'm interested in being a TA for CSE 466. Do you still need a TA? He said, I do. And the rest is history. So we started 466 in the fall. This was Jan's first class that he was teaching at ASU. Well, his first real class at ASU. He taught a topic course before. But his first real class. It was a very interesting setup just immediately off the bat with the scheduling. So it was Wednesday night from 6:05 p.m. to 8:50 p.m. So this is starting off strong. And Jan had this idea of creating a CTF course. So for those unfamiliar, a lot of us, everyone on my committee is a big capture the flag participant. Most of the people in our lab are CTF players. It's a great competition. It's a great way to learn. And so we kind of figured this is probably the way to teach cybersecurity. We should just use CTF as much as possible. So you can see the literal title of the first document that went on to become Pwn.college was CTF Course Idea. Okay, so all great things with Jan start with a yo. It's always a yo every time. It's a sudden yo. And you'll notice that this particular yo was 9:30 p.m. on Tuesday, August 2018. So the important detail, which you're probably missing, is the class starts on the 22nd. This 9:30 p.m. message is first contact for the course. Okay, so good news though, he has started prepping homework 1. We might be in a little bit of a tight spot, but we survived DEF CON, so we can do anything. This is the beginning of Pwn.college. I immediately start asking, technical questions. What should we do? It sounds like a disaster. This is my first time, in panic mode. He says, you have time to sync up. Give me a few minutes. He says, let's go to a coffee shop. Apparently this is how things get done, is the night before at a coffee shop. He's like, whatever, we'll be here. It's closed at 11 p.m. Is not enough time. Don't worry, he already knows where the 24/7 is. So we go on to create the very first version of pwn.college that night. I work on the infrastructure, creating this basic netcat thing. So you netcat at this URL, and suddenly you're presented with a dialogue saying, hey, do you want to solve the challenge? Jan works the entire night creating this monstrosity where he basically installs everything you can possibly install. And so for those with pwn.college experience, this went on to become Baby Suid, program misuse. And this was the very first assignment. So you pick some program, very different than it is now. You pick some program and you use that program to somehow leak out the flag. Now, it turns out we did in fact need that donut shop. We finished building this at 4 a.m. And I'm not even sure if it was really totally done at 4 a.m., but it was good enough for the first class. Kind of speaking of the first class, we really had no idea what we were doing. And so we were coming at this with a CTF mindset. And one of the things in CTF is that CTF is a competition. And so we had this genius idea that we would grade everyone on a real curve. Not one of those nice curves that if you've ever taken a class and gotten a curve, it's like a nice curve. No, a real curve where if you aren't at the best, you can lose score. So we were very nice, though. We made it so you could get up to 70%. And after 70%, you entered the competitive zone, which meant ultimately that you could get a 95% on the assignment, and that would dump you down to a 71% if you weren't among the best students. So we had a little bit of learning to do here. All right, detour back to science because you know what? This is a PhD defense, so maybe there needs to be a little bit of science here. So as CTF players, one of the common things we recognize probably from the beginning of our journey, and we've noticed probably in just about everyone as we watch them get into CTF, is that cybersecurity is super difficult. You go on and let's say you play your first CTF. Almost certainly you're not solving anything. You go play your second CTF, you're not solving anything. The third one, not solving anything. And you just go through this abyss of learning where you feel like you're making no progress. And then suddenly out of nowhere on your seventh CTF, you finally solve a challenge and you have this perceived perception. You finally feel like you've learned something. This is terrible. And it's actually a big problem. I think kind of one of the initial things that maybe started this idea of a CTF course was Shellfish's How to Heap. So I wasn't around for this. This is before my time. But Shellfish had these hacking meetings where they would all learn to hack together in a room. And one of the artifacts that came out of that is How to Heap. It's all right, how do we teach each other how to hack? Because CTF, while great, and we all know if you've played a lot of CTFs, you know that CTF is probably one of the best educational resources you've ever had. The beginning is terrible. And so maybe we need some sort of better methodology. Turns out the very first thing I ever said about pwn.college, what went on to become pwn.college, what kind of challenges we want, became the first paper of my PhD. So that's exactly the topic of my first paper, Pwn the Learning Curve, Education First CTF Challenges, which was accepted into SIG CSE 24. So as I just said, Capture the Flag is pedagogically non-optimal. It's educationally non-optimal. And that makes sense. It's not built to be optimal for education. It's built to be a competition. You have a whole bunch of concurrent concepts you need to apply all at once. You need to panic solve these things at 4 a.m. Bunch of people, you're spending 20 hours panicking on a challenge, trying to figure out how to solve it. Introspection and debugging is difficult. You're learning how to think about this new area all at once. Crucially, there's no cohesive curriculum. Again, this makes sense. It's Capture the Flag. It's a competition. It's not meant to be an educational resource, even though so many of us CTF players have realized its educational impact. It just doesn't work for novices. It's pedagogically non-optimal. It's a really simple solution, okay? We just redesign Capture the Flag to be educationally optimal. We take what is good about Capture the Flag, this idea of applied learning, and we redesign it so it's no longer a competition. Instead, it's a learning resource. So instead of one challenge with a whole bunch of concepts, with a whole bunch of challenges, a whole bunch of concepts, each challenge slowly building on one another, one singular concept at a time. The challenges self-introspect themselves and walk you towards their own solution. This would make no sense in a competitive environment that this like challenge is guiding you towards the solution. Though, I mean, there's some caveat to that. But in general, I mean, it's a competition. Why the heck would it be walking you towards its own solution? And of course, make a curriculum out of it, deployed as a 16-week course with lectures. So in the end, as a result of this, we had 7 topics, 2 cumulative modules, 400 plus challenges. This is like an insane amount of challenges. And one of the real crazy results to come out of this is that students enjoyed learning for 20 to 40 hours a week for 16 weeks. This is like unachievable in a standard course. And so, like any great scientific resource, we look at the Rate My Professor. 5 difficulty, 5 quality, always a good sign that you're onto something. Best and hardest class this person had ever taken at ASU, learned way more in this course than out of the entire CS program, whatever, builds up the ego. It was a great course for a lot of students. So we were, kind of on something. We got a whole bunch of these sorts of things, like very difficult, very great, spending 30 hours, spending 40 hours, like, what does this one say? Like, someone says, yeah, Jan has no idea there exists anything besides his class. That's pretty accurate. But overall, like, we're getting good feedback from this. Now, not everyone loves this. Some people think, I do have a life besides learning. And, maybe they say quality 2.0. Not for everyone, but for an overwhelming percent. All right, let's go a little more scientific. We surveyed 200 people. And of the 200 people we surveyed, overwhelmingly positive feedback. They like challenge-based learning, solving challenges is fun, etc. Okay, so kind of what we've done here is the kind of maybe the picture version of this paper is we've broken apart this learning curve. No longer is it just this massive learning wall. Instead, there's just incremental learning. You constantly keep getting, at least at a minimum, perceived proficiency. Because every time you solve a challenge, you've like definitely done something that was probably correct. And also, one of the interesting things we've kind of noticed is every time you like go up this learning curve, you're getting like a dopamine hit. So people are like getting addicted to learning with each flag they submit, which is very cool for us. Okay, let's jump into 2019. So in 2019, we finally have a web interface. Progress is being made. Very first web interface of Pwn.college. We do this thing with SSH where we make it so people can, if you've ever used Pwn.college, the way SSH works, we made that happen. So little fun technical details. We're making progress on the project. Lots of polish to challenges. So students that were complaining about spending 40 hours a week like learning, we were spending like 80 hours a week building. This was an insane task. There's no way Jan could have done anything else with his career during those 16 weeks. And for some reason in 2019, we didn't just say, awesome, we got great feedback, like let's just call it there, let's retire now, we've got a course, we're done. We basically just spent 80 hours a week again building this. In 2019, we released the first public beta of Pwn.college. We released that at HitCon 2019. We went to Japan, it was super cool, and then to Taiwan, and released the first public beta of Pwn.college. So this is a nice little website, what it looked like in the very beginning. Okay, 2020. Yo. Yeah, exactly. Yo. Everything great starts with a yo. And unsurprisingly, the first message, it's the semester starting, time to start messaging about the course again. This course starts on Wednesday, right? Or Thursday? Like, we don't even know when it starts. It's about to start, though. So for those unaware of 2020 was the year of the pandemic. So everything went online. There was no in-person class in 2020, unless I'm like misremembering. I'm pretty sure there was no in-person class in 2020. And so Jan had this genius idea of going to Canvas because guess what? Everyone at the time was transitioning their course to Canvas, was transitioning their course to Zoom, was doing all of these like normal, I don't know, most of the people in this audience took a class during 2020. Every class was doing the same thing for transitioning to online. Jan also said he's going to record a bunch of lectures, pretty standard. He also asked, like, have you heard of assigning homework before the first lecture? So my job as a TA was like making sure Jan didn't abuse like students in doing this. Turns out I didn't remember what the history was. I found the history. It looks like I recommended Twitch and YouTube, but we settled on Twitch and YouTube. And the goal was to truly release Pwn.college for free to the public. So we already had this beta where all the challenges were online. but we figured why not make all the lectures available online too, live, on Twitch, like this defense is right now. Possibly the first defense done on Twitch. And possibly, I don't think it was one of the first courses on Twitch, but it was up there in terms of teaching on Twitch. We decided on a Discord, right? So the format you're used to now came about in 2020. Jan, 3 a.m., we're getting ready to go to bed, blah, 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 blah. Let's hope for the best with this gamer stuff. Okay. Let's see how this goes.
Okay. All right, fine. We'll disassemble everything and then, as always, scroll up like that. What is going on? Baby. Okay. All right. So, I hope that's true.
So that is what Twitch learning looked like. That's what Twitch learning looked like. It was very fun. Jan also, had Melina up on his shoulders. It was a very interesting setup, but it worked. There was lots of memes that were born out of moving to Twitch, and it was overall, I think, a great success compared to Zoom. I think Zoom worked for a bunch of classes, but we had a lot of fun on Twitch, and it seemed to work. Okay, back to science real quick. So it turns out the very second thing I said, we should use CTFD, well, this is the second paper. So the first two things I ever said to Jan about what went on to become pwn.college, first two papers, all right? The ideas are easy. It's executing. So the second paper, Dojo, Applied Cybersecurity Education in the Browser. I said, we should use CTFD. Turns out we do use CTFD, so I was on to something there. It took a while before we got to CTFD. Maybe eventually CTFD will be gone, but we use CTFD. And the reason that this paper, I think, is important, and the reason that this is it's ended up the way it is like no one, like your incentives as an instructor or a professor, like it's not aligned with building infrastructure for a course. Like you want to get in and get out real quick. I mean, some people are passionate about teaching, but building infrastructure, definitely not. No one wants to build infrastructure. And so there weren't a whole lot of good options available to us for what we wanted to accomplish because, SQL is a nightmare. But before this, for kind of context, the very first version of this, this is a nerdy topic for the non-technical people here, but we had this file system database. So every time you submitted a flag, we would just touch challenge ID, user ID, just create a file, and that said you solved the challenge. And then we would LS to see how many points you had. It was pretty wild. Okay, so the Dojo problem is pretty simple. Learners need somewhere to learn. Teachers need somewhere to teach. Existing solutions don't make this easy for learners or teachers. So what do? We build a cybersecurity dojo. So we had a bunch of design goals, and some of this is more we got there eventually versus was well thought out. It's just kind of naturally unfolded. But ultimately what we wanted, I think, as we learned to realize, is we wanted this website, this platform where students could do everything at an all-in-one stop, whatever place. So at the dojo. So you could discover, you could implement, you could debug for even the most advanced and technical challenges. It shouldn't be difficult to deploy new challenges to students. It shouldn't be difficult to work on challenges. You should be able to just immediately start working on a challenge. You shouldn't have to download a virtual machine that's 20 gigabytes, and then the professor decides they want to update one challenge. Now you got to pull down this 20 gigabyte new virtual machine with the challenge. No, none of that. Completely in the browser also, so no real hardware requirements. You can solve everything we've ever done on a phone if you wanted to. I wouldn't recommend it, but technically everything is solvable from a phone. And it won't impact you other than the screen size and the keyboard. If you plug a keyboard in and connect it to a monitor, it'll work just like a laptop or anything else. It'll be totally fine. So the features, we created isolated learner environments, give people SSH access if that's what they wanted to do, VS Code and desktop in the browser, persistent storage, all tooling available in environment. We didn't want anyone having to go and find how to set up some crazy research tool. Can you imagine fighting through pip install anger and this is not happening. We're not doing this. Everything is just going to work in the environment. Just kidding. Pip install anger works. Where's fish? Yep, it works just fine. And no setup costs for learners. Just get started. There should be nothing stopping you from immediately starting a challenge. As a new user hitting our website, in 1 minute you should be on a challenge. No setup required. Okay, so here's kind of the comparison of everything that existed at the time. I mean, there's a bunch of like fine stuff that exists. Obviously, I'm going to argue our stuff is way better. And one of the big kind of ideas, I think, one of the philosophies is this like all in one place that everything can be done on the dojo, and not just like painfully done. Like you could make students suffer through doing stuff on your website, but like enjoyably done. Like this is what I would prefer to do. Okay, turns out students liked it. The dojo helps them learn. It's easy to use, blah, 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 blah. People liked the dojo. And this is what I would say kind of, if we summarize this into, again, just that picture view of what this paper is. It's very similar to the second curve, right? We still have like this step function thing, but it's brought all the way to the left, right? Like you can just immediately jump in. Maybe like that first like little line is like setting up a virtual machine, setting up your tooling, that sort of thing. And then also I would say like every single like intermediate point is quicker too, because even this isn't just like for someone that doesn't know how to set up a virtual machine. This is also for like advanced Linux exploitation where you need like this vulnerable kernel running and like you want to set up this crazy networking environment for some of our challenges. All these things, it helps at like even more advanced topics to have the tooling and the environment just already ready to go for you. Okay, 2021, we left beta. So we were no longer a beta platform. We basically just, I think the PR was literally just removing the word beta. Like, what else do you do? We started realizing kind of one of the cool things about the way that we were doing things, which is it scales really well. Like we were running a 200-person class with 2 people. Like that's pretty wild that we were able to do that for, at this point, I think 2 years, 3 years, I don't know, at that point. And we started realizing there's very nice scaling properties to what we're doing. And I realized like I had this situation where one of my students, they literally sent me a pull request to fix the dojo to make it better. Like we had this web terminal in the browser where you could like type commands in the browser and like it would disconnect you every 15 seconds and it was just like kind of awful. And a student just submitted a PR that just fixed that. So like I don't know how many classes have a situation. Now maybe you could say I should stop moving it up and it should have been working from the beginning, but it's pretty cool that like the class is being patched by people taking it. Okay, and then more, nerd technical stuff. We got VS Code in the browser. Jan saying what? That's also good. That's kind of second in line to the yo. And then we got kernel infrastructure 2.0 working. So I said with the dojo, it works really well for advanced topics also. Our first implementation of kernel stuff, it like worked nicely. But then with 2.0, most people in this room probably didn't do 1.0, probably just have used 2.0. It just like seamlessly works. Like you wouldn't even know that you're in kernel infrastructure because everything is just like feels the same. It's very nice. Okay, 2022. I quit my PhD. Okay, so spoiler, what's the word? That's the drop, I don't know what to say about that, but I quit my PhD. Here I am, so I mean, that's not too convincing. So it turns out this entire time, pwn.college was like a fun little side project. Like I wasn't really getting, I mean, maybe you could argue I was getting paid to do this, but I wasn't really, like this wasn't my purpose. As a PhD student, my purpose was to do research. And I was working on this cool project called inductive reverse engineering, which was very cool. I burnt out on it for sure. It turns out my master's thesis was on inductive reverse engineering. I think it's a really cool topic, but ultimately like, all of my time was just being spent working on pwn.college. It was like massive burnout. This is a fun battle between Jan and Adam. Adam was leading me on inductive reverse engineering, and then Jan 466 pwn.college. It was just a massive burnout. So I quit my PhD. I was like, I've been working on this for 3 years. Like, haven't even started typing a paragraph of a paper besides my master's thesis. Like, it just felt like a dead end. Jan told me no, said you're not quitting your PhD. He doesn't take a quit for an answer. He said, no, you're not quitting your PhD. And immediately he said, we're pivoting into cybersecurity education. This is the way forward. Let's just do cybersecurity education. Clearly, that's where my passion was. It was, in fact, all my time was being spent working on pwn.college. So we figured out how to transition it into a cybersecurity education focus for my PhD. And so you can see here that in February of 2022, I started this, private repo. Sorry, it's private. It has to be private. pwn.college/research, initial commit. And it was actually really cool. The very first paper I stumbled upon was in 2020 that it was published. It was a best paper award. And the title of the paper is literally, "What are cybersecurity education papers about?" I literally couldn't imagine a better thing to stumble upon. So I just literally read everything in the field about cybersecurity education. It's time to become a cybersecurity education pro. Along the way, though, research is still, research is research. We're still working on the fun stuff, like putting a browser or a desktop in the browser, doing all sorts of fun technical stuff. A big change here. I started teaching 365. So in fall of 2020, Home College was no longer just 466. We took all of the same ideas and threw it into the 365 world. Much more complicated. So we said, amazing scaling factors. Well, now instead of 200, really 150, 100, a lot of people drop out. We had 600 students. And even worse, so we had this little trick in 466 where people could just drop the class because it wasn't required for them to get their degree. So it's fine. Okay, here's the issue with 365. For some reason, Adam decided to make 365 a required course in computer science. So we did not have this leverage. It's actually a very good idea. We did not have this little trick where we could be like, oh, half of you should just drop this class because you're going to be spending 40 hours a week. They needed this for their degree. They had to get through this. So this is where we really put it to the test. Does Palm College's ideas work? So I taught first class 2020, August 23rd. Huh? There was no baby on the back. I know, it was very sad. That would have been way more fun. But we did have a nice American flag. It was a real classroom. Felt like a real teacher there. And side tangent. We'll see where this is going. ChatGPT also came out in 2022. So we're in 2022, November 30th. I don't know if you guys remember this. Maybe some of you still don't even know what ChatGPT is, which is wild to me. ChatGPT launched November 30th, 2022. Foreshadowing. Okay, 2023. More foreshadowing. ChatGPT APIs release. What the heck is this ChatGPT thing? Okay, here's what ChatGPT is. It's a large language model. If you've heard people talking about AI recently, this is the AI they're talking about. So what is a large language model? Well, a large language model works by iteratively predicting the next word in a sentence. It just predicts. It's like glorified autocomplete. And if you're thinking glorified autocomplete and you're seeing the foreshadowing, you should be worried. Okay, so and then we're talking about the scaling issue. I mean, we're saying we're good at scaling, but turns out once you have over 1,000 students in a single semester, because guess what? We released this also to the public. More than half of our students aren't even at ASU. We have all sorts of global learners. We get these emails. I'm sorry if you're one of the people that sends these sorts of emails. It's just I need help, it doesn't work. Okay, well, I've got to scale to 2,000 of these now. But actually, how do we teach thousands of students? Okay, more foreshadowing. GPT-4 came out on, March 14th, 2023. So that was pretty cool. And here's the difference of the original GPT versus GPT-4, so 3.5 versus 4, is that 3.5 was getting 10th percentile on the bar exam. GPT-4 was getting 90th percentile on the bar exam. So glorified autocomplete is starting to get real glorified. This thing is passing the LSAT, it's passing the GRE. This thing is you suddenly, I think my first experience using the ChatGPT was wow, this is cool. The computer, you can't tell it's a computer. This is amazing. And then 4 rolls around. It's oh, it's intelligent too. This is crazy. And if you maybe kind of were predicting where this was all going, that brings us to the third paper, Sensei Large Language Models as Applied Cybersecurity Tutors. That's right. We figured out if we can make a glorified, complete the sentence thing, tutor people. What could go wrong? Okay, so here's kind of our basic premise. We didn't do this completely confused about it. I mean, part of it was let's see what happens. But some of this was well thought out, right? So one of the things we noticed is that novices are really bad at providing context. When a novice is working on some problem and they're sending you an email I need help, now that's maybe a little bit of excessive on how bad that is, but they're really bad at like telling you what the heck's going on. Like, why am I struggling to solve this? They don't know how to properly articulate good questions. And it's like kind of fair, right? The whole idea of being a novice is like a big component of it anyways, is that you don't know what you don't know. Like you don't even know what's relevant that you're looking at that like could help a tutor help you. So novices are bad at providing context. In our case, novices are working in the dojo. So this is maybe unrelated, but this is true. The Pwn philosophy provides context. So one of our things we do is like we provide all this self-introspection on the challenges. The challenges are like walking you through its solution. It's telling you all these like debugging values. It's helping you along. And one of the things I'll argue is all you need is context. Context is all you need. So the very next thing we did to make all of this kind of connect, so we have this like thing that can complete the sentence. Now all we need to do is give it eyes. So we give ChatGPT eyes, we call it Sensei, and now this thing is able to look over the student's shoulder and watch them as they are working. So now when you get this email, and maybe you're Sensei, you're this ChatGPT tutor thing, you get this email. Well, it doesn't matter that this is all they told you. You're looking at their screen. You can see their current file that they're editing. You can see their terminal. Like, even if they just say it doesn't work, this context here, especially if you know these like boxes make any sense to you, you would understand that this like is very insightful context beyond it doesn't work. Let's just throw it in an LLM. So I am a world-class cybersecurity tutor. A student just reached out saying, I need help. They are working on a file with the contents move 0x1337 RDI syscall. They are working in a terminal that currently says ASCode.S-O code.O error unsupported instruction move. So in response, I tell them, right? Isn't it easy, especially if you're non-technical, to just complete that sentence? So it works, right? It completes the sentence and it provides guidance. It provides tutoring. We can actually shape its responses to not just give you the answer, but to be a tutor. And so this is kind of a simplified version of it. Our actual like initial sentence, much longer. We're able to make this autocomplete system actually help a student figure out what's going wrong. It's like kind of mind-boggling that this works, right? Like it literally says, remember the syntax for move is move destination source. Like just reading this, it's like an autocomplete. It's an autocomplete that like knows something. It's very bizarre until you play around with it for a while. Okay, so we built this system, Sensei. We're very reliant on the fact that everyone's in the dojo, which means kind of we have this box, very nice technical diagram. We have the ability to introspect everything. They're on our server, typing their commands, editing their files. It's our server. We can just introspect everything happening and give eyes to this system to watch it as the student types commands or edits their file. It's not as dystopian as it sounds. And then we send this off to an LLM when they ask a question, like, why am I getting this error? LLM does its thing, boom, provides us the response, and it provides helpful guidance. Okay, Sensei usage. So we deployed this thing. I should know this. In July. I'm almost certain we deployed this in July of last year. Critically, though, we studied its usage for 6 months. So in total, we had 852 unique learners that worked on a combined total of 504 unique educational challenges. A total of 34,108 messages were sent into the system across 3,583 sessions. So a session being like a unique pairing of a challenge and a learner. So basically, it provided guidance 3,500 times and like potentially long back and forth sessions of guidance. And the total cost, because everyone's wondering, how much does it cost? It's $1,500. Like it's not so bad, right? Like you're able to have 3,500 helpful interactions for roughly the cost of like an undergraduate TA. Except it was able to talk to 852 learners. I think that's some reach. Now, probably the undergraduate TA, I'm not making fun of all my UG TAs that are here. You're probably better than Sensei. But the question is like, how useful is it? What is the impact? Is it useful? Okay. So we analyzed this in a number of ways, quantitatively and qualitatively. So I read over 500 of these sessions, just like going back and forth, like, is this a good tutor? Is this not a good tutor? And we found one of the interesting stats to come out of this is there were times, a lot of times, when a student would be messaging Sensei and there would be no context. So not like their terminal and their file, neither of those were being sent to Sensei the entire time. Partially due to this being a massive engineering problem and this being a research task, those two don't necessarily go the best together. If you've used Sensei and it's bugged out on you, it's because I need to do more engineering work on it. It just like would fail. But fortunately, this gave us a very nice representative understanding of, well, what happens when the context doesn't go? Well, what happens is, on average, a median, your time to solve a challenge after using Sensei is 43 minutes and 48 seconds. So my interpretation of this number, and the interpretation we argue in this paper, is it doesn't give you a whole lot of information. Like, the Sensei could have been useful, and then it kind of quasi helped you, but there was a lot going on, so eventually you solved it later, and like maybe it was useful, maybe it wasn't useful at all, right? If you go talk to a human tutor and like it takes you another 43 minutes to solve it, probably that tutor wasn't so useful. But like it's hard to interpret that number. A much easier number to interpret, I would argue, is active context. So active context meaning every single time you send a message to Sensei, either your terminal or your file change, which means you're actively following along as Sensei is providing you guidance. You're doing things in response to the fact that it's providing you guidance. 3 minutes and 46 seconds. Okay, so when I said context is all you need, context is pretty useful. That first thing, no context, is the I need help, exclamation point, exclamation point, exclamation point. Active context, the file and terminal are being sent along with it. So we see,
Connor,
yeah.
can I ask you something?
Absolutely.
I understand this differentiation between no context and active context. Can you give me another practical example, please?
Yeah, so if I go back to this diagram here, so this diagram right here is showing the fact that as part of the Sensei system, there is a terminal and there is a text editor that constitute what we call the context. So the context being like, if I'm a human tutor looking over someone's shoulder, I can see them typing on their laptop, editing some file, or interacting with their terminal in some way. So this is the context. It's not their question, right? Below it in the Sensei front end, we see a question like, why am I getting this error? That question, I mean, we say it's a different type of context, let's say that. The terminal and text editor context in that first situation, for whatever reason, and there's a whole bunch of reasons, the terminal and text editor context just don't appear to Sensei. Sensei is not able to look over your shoulder. Like Sensei is just wearing a blindfold and cannot see your screen currently in that scenario. Whereas if we take the blindfold off and allow Sensei to look at your screen, to look at your file as you're working, the median time drops. And specifically, this word...
Sorry.
Yeah.
No, okay. Just so if I understand. So you're saying that your concept of no context is just a student interacting with the LLM, providing whatever they provide, saying, hey, I got this error. What does it mean?
Exactly. No context is just human.
Context.
Yep.
Okay, and the active context is unbeknownst to the user, there is some capturing of his kind of operating environment that is actually leveraged in the prompt.
Basically. So technically, the user can see the fact that the terminal and the file are being sent to Sensei, but it's mostly a background thing. Like, this is just like a UI. We technically surface their terminal. I'll show in a demo at the end what that looks like. But yes, exactly. So an active meaning specifically, every time Sensei sends them a message and they want to send another message, like they either type a new command on their terminal or they edit their file. So they're following along with Sensei. It's like a back and forth active engagement with Sensei where we have this active context.
How do you know that the actions that they take next are in consequence of what they discuss with the Sensei?
So we don't know that. We don't know. We just go off of the median time of after using Sensei, how long does it take you to solve the challenge? All we do for computing this metric is saying that something changed. And I don't have this, unfortunately, in this presentation, but we did like a deep dive kind of into what the distribution looks like in terms of like a user messaging Sensei, Sensei messaging back, and then a user messaging again. Normally, these sessions are like quick back and forths. Like if you're in a session, it's a back and forth. Normally, you don't send a message to Sensei and then disappear for 2 hours and then send another message to Sensei. That normally isn't a common characteristic of people using Sensei. Unfortunately, I don't have the hard stats in this presentation, but that's something we've analyzed. Does that answer your question?
Yeah.
Sweet. All right. So we also broke this down on a per module basis. So unsurprisingly, Sensei is far more useful on the easier challenges. So for example, those familiar with pwn.college, Sensei is significantly more reliable at helping you with talking web than it is with helping you with, I don't know, like speculative execution, right? It's probably not surprising. But one of the things we wanted to understand in looking at this data set, right? We had 3,500 interactions. Is like, why exactly is that? Like, it's intuitive that the easier things can be solved more easily with the help of Sensei, that like maybe there's like less knowledge required and Sensei possesses just that lesser knowledge, but it's enough to solve the challenge and help the student get there. Whereas maybe it doesn't know as much about speculative execution and actually applying those concepts. So it's kind of like intuitive, but we wanted to dive into like what's going on here. So one of the big things that we discovered is kind of like obvious example of this is somewhere in the middle here. It's kind of hard to see a little bit with all these modules. Somewhere in the middle here is debugging refresher. So debugging refresher, in terms of Sensei's ability to help, at least as defined by solving the challenge after receiving help from Sensei, debugging refresher intuitively should not be at the middle. Debugging refresher is one of the easiest modules we have on pwn.college. It's like a quick little primer on how to use GDB if you've never done it. And it's like 8 challenges that really, really, really walk you through its solution. The issue is that the challenge revolves around GDB, and GDB produces an insane amount of text, like so much text, nonstop, lots of text, to where we've got this context window. So I guess something I didn't explicitly mention here. We're limited to 8,000 tokens, or about 6,000 words worth of context in total. But given the constraints of GPT-4, these constraints are vanishing with time. But that's currently our constraint, is 6,000 words or so of information. And GDB just like explodes the terminal with lots of information. And our naive approach right now, where we're just sending the entire current state of the terminal, it's too much information. And we report to the error what's called like a context overflow. And Sensei is like unable to help because the terminal is so filled with information. And like that literally just can't be sent. Now, there's probably some good solutions to this problem. But in the current implementation of Sensei, that's just a reality. And so this constraint of like, if there's a lot of text involved in solving it, you have an inability to kind of see all that text. It's like less information dense text and a lot of it. It's just not good for Sensei. One of the other things we noticed, probably the biggest thing we noticed of thinking about how to understand what's going on in these helpful sessions, is what I've termed reflexive intelligence. So while Sensei is helping you, if Sensei can like notice something, like for example, the easiest example of this is like a syntactic error. So the email example I showed before, where they had the source and destination register and value flipped, this is like a syntactic issue that ChatGPT or GPT-4, it just recognizes this and like almost as a reflex, it understands what's going on and can like talk to you about it like very informatively and very helpfully. Where this fails and where this breaks down, unfortunately, is in some of the harder challenges where there's a lot of debugging. So I mentioned GDB as like in terms of it overflowing the context window. That's not the only issue. The ability to form an understanding of the debugging process like GPT-4, it can't do it. I think probably one of the better ways to think about this is in terms of like science itself. So one of the big things that happens while you're reverse engineering something and while you're debugging something is you're like constantly forming these like little hypotheses, and you're like invalidating these hypotheses. Like you're not going into the situation with full knowledge of what's going on that you can just like have a reflex to. Instead, you're just creating these hypotheses, invalidating them, and just like understanding what's going on. You're kind of in this unknown territory that novices struggle with. Makes sense, right? Unknown is never a good thing. But someone that has more experience, one of the big things that we try to teach in PwC is building up this like scientific mindset of debugging where you're invalidating these hypotheses. And unfortunately, GPT acts as if it knows everything. And it just doesn't need to form a hypothesis. It just knows what's happening, and it will tell you what's happening very confidently, even if it's 100% wrong. It doesn't know that it's like currently in this uncertain territory where it needs to like start really digging in and debugging this and like, what is this value? I think this value should be this value, but is it like, let's set a breakpoint here, let's confirm. Sensei just doesn't know how to do this. GPT-4 doesn't know how to do this. It remains to be seen. Hopefully we can use some cool tricks to convince GPT-4 it knows how to do this. Maybe there's techniques called like fine tuning. Maybe there's ways to start getting this in, but this is where like that deeper level of intelligence really is required to offer assistance. And unfortunately, we're just not there yet. It's still, ultimately, it's just a complete the sentence tool. And so in this way, I kind of would characterize, after looking at over 500 of these sessions, that Sensei just has this reflexive intelligence. If it knows it, it knows it. Otherwise, good luck. It's going to confuse you, which is not good for students. Fortunately, all that being said, these are definitely limitations. Fortunately, students on average like it. It doesn't solve education. It doesn't 100% solve the scaling problem. It's a tool. It's a useful tool that kind of offers a quick glance, second perspective on what's going wrong. It's not in office hours. It's not a recitation. Ultimately, humans still need to be a part of the equation, at least right now. Maybe in 2 years, not so much. But right now, humans still have to be involved. But it offers like this quick, like, what am I doing wrong? What is this like reflexive intelligence that I'm missing? It allows the system to say, oh, I see what you're doing wrong. Let me show you what you're doing wrong. And if it can't do that, then it's all bets are off. Okay, so I said $1,500 were spent. Turns out this is just the month of February, and we're halfway through the month of February for those unfamiliar. Okay, already before the submission of this paper, I'm pretty sure we've at least doubled the usage of Sensei. So if this isn't convincing that Sensei is maybe like useful in some ways, okay, our budget is exploding rapidly. Okay, I don't know why we have the sudden uptick of usage, but we got a lot of usage. So now Adam and Jan are hearing this for the first time.
Yeah. Is it bad if it's useless?
It's not. It's definitely not useless. It's definitely not useless.
What if it's negative?
That in some cases it might be, but on average, no.
And we're paying a lot.
And you're paying a lot of money to confuse students. So I would argue, though, especially for a lot of these introductory assignments where someone is just getting started, like you're writing assembly for the first time and you just like don't even know what you're looking at, right? Like you're just lost out at sea. Sensei is very, very useful here. Unfortunately, it doesn't help us with these harder problems quite yet. In some cases, it does a little bit. But I would say that Sensei is overall useful. It's a useful tool. And so kind of the idea here, right, is that we're just reshaping the learning curve a little bit, making it a higher upward trajectory a little bit faster. Okay, 2024. Demo. Okay, so what the heck have we built over the last several years? Let's see here. Well, let's do a quick example. Okay, so we've got this website that we've built. Okay, we've got all these courses, all these cool dojos that people of our community have built. We've got these belts. I don't know if you can see this. We'll put it in the camera also. We've got belts that you can earn. Let's go ahead and see where we've come in the last 6 years. So we've got memory errors. So right now we're using the dojo in case, it's probably not clear to some of the people that have never seen this before. We are using the dojo right now. So that's paper number 2. We can start up a challenge. And I'm really hopeful that this live demo doesn't fail miserably.
I was pushing pages.
Yeah, exactly. And then we can go over here to the workspace now that the challenge has been started. We've got VS Code in the browser. Pretty cool. So we've got this terminal thing. This is how, for untechnical people, this is how you talk to a computer, basically. Okay, you type commands at the computer. And then also just to show it, because the dojo is awesome, we've also got a desktop in the browser for you non-technical people. This is probably more what you are used to, right? You can open folders and stuff. Very cool, all in the browser. Okay, but we also got the terminal. Terminal is a little more common in the computer science world. And we've got the second paper. We've got these challenges. Oh boy. Challenge, okay? And we're super zoomed in, so it's a little bit awkward to look at. But this thing just print out a whole bunch of text to us. This thing is debugging itself. It's telling us, okay, here's what memory currently looks like. We've got a bunch of bytes in a row, this thing called memory, a bunch of values in a row, all these numbers that are from 0 to 255 in a row. I don't know, maybe I shouldn't go too non-technical here. Use pwn.college if anything I'm saying doesn't make sense, and you can learn about this stuff. Okay, so it tells us everything that's going on. So we've got this function that's running. It tells us, hey, your stack pointer is currently here. Your base pointer is currently here. Input buffer is here. There's all addresses, like house addresses almost. We've got these variables that are available. The buffer right here, this thing is 51 bytes long. But the program will let you provide an arbitrarily large input. This is what's called a classic buffer overflow, and thus overflow the buffer. See, it says buffer overflow a little bit. In this level, there is a win variable. By default, it's 0. Okay, this is the simplest thing. We don't start someone off in some difficult challenge where they got to learn 30 things at once. The gist of what this is saying, since I'm sure all of you don't want to read this right now, is let's overflow this thing. We've got our buffer. We've got a variable over here. You can send some data, however much you want. Let's do it. Let's say I want to send 100 A's, and I get bored, and I said that. Okay, it didn't work. It said goodbye, and it tells us the value of the win variable is 0. Somewhere up above, it said make the value of the win variable not 0. Okay, I have no idea what's going on. Oh, you've got to be kidding me. The Mac OS bug. This is going to be fixed eventually. Okay, there we go. Okay, look at this. This entire time, Sensei's been watching. It knows what our terminal is. It can see it. What did that one email say? This isn't working. Hopefully, all of you aren't at home right now using Sensei and somehow breaking Sensei. It's got engineering work that is required. We're really hopeful for this live demo. Okay, let's zoom in. Can we zoom in? I see you're trying to overflow the buffer to change the value of the win variable. However, it seems like you're not sending enough input to reach the win variable. The win variable is stored at blah, 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 52 bytes after the start of the input buffer. How many bytes of input did you send? And how many bytes do you think you need to send? I don't know, 10 bytes. How many I need? Yeah, this is what most of the interactions look like. Oh, well, it tells me how many I actually sent. You can't lie to it. It can see right here that it says, you sent 18 bytes. It caught us on camera. Which is 52 bytes after the start of the input buffer. You need to send at least 52 bytes. Try sending more bytes. All right, let's send more bytes. Hopefully that's enough bytes. Oh, you got the flag. Whoa, it worked. But why? So maybe maybe it did blindly lead you to the solution. on average, we really didn't notice too much of it like helping too much, like just offering you the solution. It really does follow like this educational focus. Now, maybe a student won't ask why, but it's available if you want to learn. Like, I don't understand how the heck should I solve this. This is like a thing on our heap module, one of our modules in pwn.college heap. There's like a bunch of people that like just type random operations on the heap. This is very technical. You do like random operations on the heap and suddenly you just get the flag. You have no idea what happened. Well, this thing could explain to you what the heck happened. And it tells us, well, good job. You sent 100 bytes, which is 52 bytes after the start of the input buffer. You overwrote the win variable, changed its value to 0x4141414, which is AAAA in ASCII. This is why the program printed the flag. Do you understand why this worked? And you could just keep talking to this thing, racking up that cloud API budget, and all would be good. Oh boy, that's terrible. All would be good. Oh no, that's even worse. Oh boy, that's terrible. Okay, how do we go back here? All right, so that's the demo. Some stats. So we've built pwn.college. We started in 2018. Where have we gotten so far? So we saw the demo. The demo is maybe an applied version of where have we gotten. None of that existed before 2018, or we built on the shoulder of giants. Some of it existed, but a lot of that stuff is what we have worked on. So we've been working on the Dojo project specifically since August 16, 2020. Very nice day, August 16th. And we've gained a whole bunch of users. So specifically, this has been since 2021. We kept resetting the instance every year because, this was just like for 466. This wasn't this public thing to the world. I think technically I have the database for 2020. I don't know, 2019, don't have the database. 2018, there was no database. It was just a file system. And this is how many users we've had. So I don't know if you noticed this. The blue area is the global, as in not ASU. The other color is ASU. By far, most of our users are non-ASU students. And you can see here this tiny little sliver. This was back when there was only 466. The only reason we have so many ASU students is because of 365, that it really started jumping up. And you can see every time a semester starts, it like jumps up on the ASU side. We seem to have I noticed, I don't know what's going on here. We've got a good upward trend going on recently. The derivative is going up or something. That's what you'd say in math, I think. And then we've got solves over time. So we recently hit over 1 million. This month we hit over 1 million solves, which is pretty cool. We hacked into everyone's terminals and started playing this cool video of Karate Kid. So that was pretty fun.
Sensei.
That was,
Sensei liked it.
Yeah, Sensei. Yeah. Yeah, that was actually a disaster. Sensei, who was watching over everyone's shoulders as Karate Kid was playing, was not thrilled. And then we've got a whole bunch of people that have earned belts. So in the beginning, there was only the yellow belts. And then the blue belts came along. And then the orange belts came along. That's why it's there. Probably we need to figure out how to retroactively date some of this stuff because it's kind of weird, but I don't know. A bunch of people immediately had it.
I have a question. It's on your website, you have a progression like white, orange, yellow, green, blue.
Yes.
Which is usually it's like white, yellow, orange, green, blue.
Yeah, we follow Jan's Taekwondo studio, so take it up with his sensei.
Is that weird stuff that Jan does?
Yeah, for some reason, Jan went and got some black belts in Taekwondo, so that's what we're following.
All right.
I don't get it either. I did karate as a kid. This is definitely the wrong order, but we just roll with it. And so you can see by far the most is orange. So we make it pretty accessible to get orange. I think it's something like half the students in 365 end up getting orange, whereas yellow and green now actually are 466, and it's not as nice. We kind of have some really difficult challenges embedded in there that are we expect students not to solve, and we just hope nobody complains that you're not expected to solve everything. And then also green is new. We keep rechanging things. I hope we don't end up with a camo belt. According to Jan's Taekwondo studio, somewhere in this progression of orange, yellow, green, blue, is it after yellow is camo? So technically we have room to put a belt between yellow and green. It would be a camo belt. I don't think this is going to happen, but technically.
Camo? There's no camo.
There's a camouflage belt. It's insane.
You tell that to Mr. Huff too.
Uh,
You just can't see it.
and I think our goal is to keep expanding our content, including more difficult content, possibly, like a master's program at pwn.college. Oh, there's a question. We got a raising hand. We got also 545 on the dojo. Pretty cool.
That's probably the uptick because we got 3 sections of I-45.
In fact, I was looking through the sensei logs, that budget of going to $900. I can tell that you're telling your students to use it.
I told them once, and the online students are very,
Yeah.
they like using it.
I see. So the secret is, for sensei to maintain the budget, is I just never told anyone about it. We just added a help button to the top and just pretended it didn't exist. That way we could keep the budget in line.
Told me about it. I mentioned it.
Yeah, it's a disaster. And now the budget's wild.
So you are an hour in at this point.
Yes,
right?
we're almost done.
No, I have to tell you that I hard stop at 5:40. So you have 40 minutes.
Oh, yeah, we'll definitely be done with all of the process by.
I just want to give you some boundaries.
Yeah, thank you. Yeah, we'll definitely be done with the whole process by then. Okay, so one other little stat that's kind of fun to look at is our monthly active users. So every month we have over 2,000 users. You'll see that in January we had this huge spike, and it's not just because 365 and 545 started in January. This lighter blue right here. You can see my mouse. This thing right here is new global users, as in not ASU. I have no idea where these people are coming from, but I don't know. So I guess people are suddenly using the dojo. We'll see. It's pretty cool that we're able to extend our reach beyond ASU. And in fact, we're able to expand our reach all across the globe. So these are the top 20 countries listed out here. Obviously, United States is at the top because, it's built here and we literally use it at ASU and blah, 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 blah. But also India has a bunch of people. Italy has a bunch of people. You can see all these 20 top countries, hundreds of people from around the world in each country. And in total, we have users from 144 countries. Now, I will say, this is a long tail, at the end, it's one user, one user, one user. There is a thing called a VPN. And, being in cybersecurity, people are more likely to use VPNs than outside of cybersecurity. It's hard to say if people are VPNing to some of these one user countries and if it's really 144. We definitely have a lot of countries that are all using the dojo. We know of, I don't know, at least 6 countries with universities using it, right?
At least 6.
At least 6 countries. We know
Where's
UK is using it. There's all around Italy is definitely a country. Yeah. We know of a bunch of schools that are using it, a bunch of universities. So here's our YouTube analytics for the like and subscribers. We've got more than 7.5 years worth of watch material. So this is just YouTube. Twitch, we do live. Twitch doesn't give us the cool analytics. It just is the last month or something. So on YouTube, we've had more than 7.5 years worth of watching. Okay, this next stat is hard to do. This is the first time Jan is seeing this stat. We maybe have more than 200 years of hacking. So this is a very hard thing to compute because we don't know actually when you're in the dojo environment. All we have is when you solve a challenge, what time, when you solve the next one. I'm doing some pretty complicated stats, statistical stuff to try and remove outliers and stuff. It's definitely at least 100 years of hacking. I think 200 is probably the most accurate. Technically, in range, could be 300 years of hacking. I think 200 is probably a good number. A lot of years of hacking. So that's 1.75 million hours of hacking. So that's pretty cool. We've got more than 200 yos. That's a good stat. This is where all the ideas happen. And we've gotten a lot of feedback over the years with very nice, all sorts of feedback from our surveys, feedback on the Discord. In this case, I don't think I've shown this, so we're going to show some of the email feedback. We get very nice emails from people. So this is one person saying, "Home college is awesome. We love to hear it." They started at some university and they're teaching, and they ended up and continue to use pwn.college actually to teach their course, which is really cool that they are able to get value out of something that we did. Another person, this person actually forked the dojo, so they're not actually using the dojo like pwn.college. Instead, they forked it. They made some modifications, so everything's open source. So it's pretty cool that people are able to like modify the dojo as they see fit. I think they're using some of our challenges, but I think they might also have some of their own challenges. Everything's just open source. People can use this stuff however they want. This person is like constructing exercises in networking for post-high school students. So that's pretty cool. This person actually has like their middle schooler and high school schooler running through it, and like we're working on 365 on reverse engineering. After 2 to 3 weeks, they got through a lot of that. They said Sensei helped, so that's cool. And so does the Discord. I haven't mentioned the Discord that much really here. Fortunately, there's no Discord paper to come later, maybe. The Discord is very cool. I got this very nice email actually recently. So I got an email with someone that thanked me for citing their work. So we finally started publishing. So that's really cool to see that someone was such like a fan that's actually in the cybersecurity education research world, and they were a really big fan. And then I think this is probably the next one is the nicest email we've got. It's really heartwarming. I'll read it. This is one of the greatest accomplishments of my life, Yellow Belt achieved. I started around when my son was born, and he just turned 1 yesterday. It was one of the hardest years of my life, but gosh, has it been rewarding in so many ways. Thank you so much from the bottom of my heart. You gave me somewhere to take my mind when things were difficult at home. I really look forward to placing this belt in a display case right alongside my diplomas. So we've received some very heartwarming emails from people over the years, which is really encouraging to keep working on this. Okay, so I am definitely out of time by now. Don't worry, the slide is in there. I knew this was going to come, but we're at the conclusion here. So we've kind of built this platform, pwn.college, over the last 6 years, and our philosophy is simple: practice makes perfect. And this is the same philosophy that was on the very first document of pwn.college. From the beginning, we knew that the core idea of pwn.college is practice makes perfect. And going back to the very beginning of this presentation, actually, where I asked Jan, hey, you still need a TA? And, he said, I do. And then we had the meme of the church and the wedding and stuff, blah, 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 blah. Okay, I didn't show you the next message. Are you sure you don't want to focus that time on research? I enjoy the distraction. I don't think it should have too much of a negative impact on my research. It turned out to be true. pwn.college ended up being my research, so it's pretty cool. And that is all. Thank you.
People clapping, I don't hear anything.
It's the beautiful noise cancellation. Sweet.
Yeah.
Thank you, Connor. That
Absolutely.
Wait, hold on. Clap harder.
We just finished the speech.
Now it's the questions and answers.
Awesome. So let's open it up to questions for Connor.
Why don't you describe the process?
Yeah, the process is as such. We all do questions. If you're on Twitch or Discord, ask your question and I'll relay it to Connor, unless you've got it open or something.
No, I don't have it.
Yes. Keep in mind of the time limit. So we'll do maybe 15, 20 minutes of questions, and then we'll do roll on to the next closed session. So first, in the PhD defense, we all ask him questions, try to trip him up a little bit, and then if he makes it through that, then there's an intense closed session with just the PhD committee where we try to trip him up. And then if he makes it through that, then we also eventually kick Connor out, and then we have a closed session discussing that, and then he either makes it or has to do all this again. All right, awesome. If you're on Discord, don't forget to vote on whether Connor should pass or not. Let's open up the questions.
What was the question?
I actually do have one. Who made the brownies?
Julia. My fiance Julia made the brownies. Yeah, they're very good. She's a professional baker.
Really?
Not actually, but in practice, yes.
Very good brownie.
I have a question.
Yeah.
I don't know how busy you guys are there. But
Go for it.
Can I go?
Yeah.
So you said, that you read everything in cybersecurity education, and in your, I found sort of the in this presentation the related work part. There was that beautiful table with all the various, from various frameworks and various working sites and all that. However, I haven't seen a comparison in the bigger picture of general computer science education and what's going on in that context in terms of online support, of tutoring, and what is the specificity of security with respect to that world? Can you say something about it, and what do you think is relevant from this point of view?
Yeah, so most of the research in the computer science world is on intro to computer science. So one of the big players, at least in terms of research, but also I think in terms of computer science, is the thing called CS50. So they're out of Harvard. They also looked into using GPT-4 as a tutor within their CS50 platform. So their most of their tasks, I think, are in like very basic Python programs that they're writing. And they found overwhelmingly that it does great. So they found like kind of the same thing as us in terms of it works great for easy things. The way that they deployed it was a little bit differently. So one of the things that they did with it, for example, that as you're getting into computer science, something you're not necessarily very good at is code formatting. So they have GPT-4 acting as a helper in terms of figuring out how to format your code like nicely in a way that everyone appreciates. They also have it kind of, their model is different in that they built it into VS Code, and they make it so that you can like highlight a section of code and then ask a question about that piece of code. Again, this is for much easier programming tasks. So, I mean, we also apply, I guess, to easier cybersecurity tasks, but maybe unlike them, we went further in terms of seeing how does this do against advanced things. And while overall we found it doesn't do so great against advanced things, we also found some areas where it does do well. So for example, I mean, I showed you for the basic buffer overflow example, but it can also, I guess as an example, it can start walking you through writing a pwn script. So writing, like that's a syntactic task, but it's like crucial in the field of cybersecurity, depending on the topic, to be able to do that. And it performs excellently at that sort of task. I guess in terms of broader computer science, just even outside of AI, which is kind of the, well, specifically LLM AI and using it to help students world, most of the research that exists is also still focusing on introductory computer science stuff. There's not a whole lot of stuff going into more advanced topics. It certainly exists. It's just not one of the bigger things. Like everyone's just interested in like figuring out how do we get people to start coding, for example. Like how do we get people interested in it? Like what are the activities we can do, for example, that don't even involve a computer to get people like excited about it, like going back to middle school, high school, that sort of range. I would say one of the more interesting takeaways that's a little bit unfortunate is that the world of education is certainly in the cybersecurity field, though I think it also extends quite a bit to the broader computer science world, is there's like this, it feels like a little bit of a lack of rigor. So if you look at kind of the top 4 cybersecurity conferences that, you know, we're kind of more familiar with publishing, and there's a higher level of rigor there for confirming some of your results. In education, it's a little bit more like experience report-y, which is kind of unfortunate. Like there's definitely, it's unfortunate because like sometimes people are just writing about like, hey, how did I run my class? And they're not even like necessarily exploring some new idea, which I think is a little bit unfortunate that people aren't, I mean, to be clear, people are figuring out how to push the bounds of education. It's just, it doesn't have that same like fieriness to it as I see in like top tier cybersecurity conferences where people are trying to push forward really hard the state of cybersecurity. It's a little bit less so in education, which I think is unfortunate, but hopefully we're able to start making a dent in trying new things and really, I mean, given the fact that we have this pwn.college platform with thousands and thousands of users, I think we're able to start really, I think this is almost like the beginning for research for us. We're able to now start conducting real studies, educational studies across thousands of users, which I think is a really cool opportunity.
Got it.
Yep. Eric?
So what about going beyond cybersecurity or CS? Are there any plans to adapt
For
like the
pwn
functionality?
college? Yeah, so I mean, that's kind of, I would say currently more of a passion idea, not necessarily being implemented yet. But I think a lot of these techniques could do very well in broader computer science. In fact, I think we're already kind of just like, without fully willing to admit it, like we already kind of are at broader computer science in terms of when we're exploring like a buffer overflow, we're showing how memory layouts actually work. Like how does the C runtime work? How does the stack actually work? Like you take like a intro to C class and you learn about this thing called the stack, you learn about this thing called the heap. These are things for storing memory. Like one is malloc, one is local variable, and we're done. But I think already we're doing it from this cybersecurity framing, but already we're like, I think we're really pushing deep into the core of computer science and how computing like actually already works. I think it would be cool, that being said, to, for example, the Dojo platform and the pwn philosophy and Sensei, all three of these techniques. So, for example, like we have CSE 230 here, where you learn about MIPS, which Jan always memes on. It's not necessarily the worst thing in the world to learn MIPS, but more fundamentally to learn about computer architectures and learn about like assembly programming languages. I think these ideas would translate very naturally there. Like we already have an assembly crash course module that we could split out into like 10 modules and really use this like practice makes perfect mentality with all the bells and whistles to go with it in other courses for sure. It's just a matter of time. Eventually we'll take it all over. We will, yeah.
When you were doing your testing for Sensei, you combined both the terminal and file system changes, right? But did you ever explore doing just one or the other and seeing how that actually impacted its...
Yes. So it's a little bit hard to measure that. But we, in the paper that is under submission right now, we do have a breakdown of, we have like 9 categories where we have no context at all, no file context, no terminal context, some file context, some terminal context, some everything context, and then active of all 3. We have that breakdown in the paper. So one of the reasons it's like hard to really reason about that is a lot of our modules just, you never edit a file. So for example, we have something like building a web server where you're writing this assembly program, you're definitely editing a file. I mean, you could find a way to solve it without ever editing a file, but you're editing a file. I haven't found an example of someone solving it without editing a file. Whereas we have something like Talking Web. I'm thinking 365 modules that we've just done in the last few weeks. Talking Web, where it's like, how do we make web requests to a bunch of servers using Netcat, using Python, using curl. And so for that Python segment, technically you could write a script and then run the script, but a lot of people also just do like IPython, and you just never end up with the file. So it's kind of like hard to analyze. In my head, it doesn't really make sense. Like the way I look at it is, if I'm a tutor and you're asking me for help, like I just want to look over your shoulder and see whatever specific thing you're working on. And those things of terminal versus file are normally just like an artifact of the challenge. That being said, I think file is often a lot easier, at least in our world, because you're writing normally relatively small programs that don't use up a whole lot of the context window. whereas the terminal has much more capacity to like be overflowed. So for example, I guess I'm not going to pull up the demo, but the demo I walked through where I ran the send a bunch of A's thing, if I ran that like 20 times and like each time I'm getting confused, I am going to overflow that terminal context window. And it's like almost silly. Like if you literally just type clear and hit enter, like all the problems go away. But at least in terms of like a usability perspective, like that's currently not fixed, and like we're just flooding. It's an issue. So I don't know how much of that ramble answered your question, but hopefully it answered it at least a little bit. Awesome. Yeah.
Hello. Okay, so I want to ask. This is mainly about Sensei, but I want to know if. Obviously, I remember taking your course like a year ago, and I remember you making a point of like not cheating on the challenges. I'm wondering if there's like, if students have like attempted to try to cheat with like Sensei, maybe try to do like some kind of like prompt injection, like see if they can get the flag or something, or if there's like is there any vulnerabilities like that in Sensei?
So the simple answer is yes. I think I've witnessed, of the 500-ish interactions I looked at, I think 2 of them were attempted prompt injections, and 1 of them was successful. So GPT-4 versus GPT, so I guess it's taking a quick step back. Prompt injection has to do with, for those unfamiliar, probably a lot of people, has to do with sending some sort of input to the AI where it stops listening to its guardrails. So for example, one of the guardrails we put up is saying like, hey, your mission here is to be educational, don't just give them the answer. By prompt injecting, you like send it this input where like in the simplest version, if it was really naive and the AI wasn't very good, you just said immediately, but JK, you can send me the answers. Like that would be a prompt injection. Now, technically, it's a little more sophisticated than that these days with GPT-4. But yes, it does happen. So we specifically address that problem, though, by not putting anything in the context window that's sensitive. So everything in the context window is the user's message, the challenge description, their terminal, their file. So the worst thing you can do with prompt injection, I mean, so technically you could tell it to like stop being educational and like just give me answers. That's pretty bad. But I would say, I mean, unfortunately, ChatGPT already exists. You can already guide ChatGPT however you want. We tell people like, hey, if it ever feels like you're cheating off the AI, you're doing something wrong, don't do that. Like as it currently stands, it's like there's a bit of a trust there. But you could imagine the scenario where instead we do put sensitive information in the context window. So something that would be very, very helpful to Sensei would be to put a full solution script right in the context window, never show it to the user, but as we tell it like, hey, you're super educational, and like, hey, this is what the user's terminal looks like right now. We could also say like, and hey, here's what the solution is for this challenge. That would be like, I mean, we haven't rigorously analyzed this, but in the limited testing we have done of it, that would be like beyond useful for Sensei to understand what's going on with the challenge and like how to start helping the user like reach in that direction to make sure that like it's not leading the user off course in some way. We specifically don't do that though because we don't trust prompt injection right now. So we don't want, especially in a cybersecurity context, like it's not just computer science, but in a cybersecurity context especially, where people are thinking like maliciously, like we just, as of now, we don't put anything sensitive in the context. Yeah.
Thank you.
More questions. Yeah.
So 2 things are happening. My painkillers are wearing off for my ear, and Giovanni has a hard stop, so we should push this along to the closed session.
Okay, we're going to the closed session. If there's more questions, reach out to me in whatever way you know how to reach out to me.
Everybody, thank you for coming. Let's thank Connor again. Remember that.
Yeah, what's happening with your painkiller in your ear?
I have an ear infection, Giovanni. It is so painful. Brooke said that. Yeah. Brooke said that I look like she felt when she was giving birth.
All right, thank you everyone watching the stream. We'll report back on the Discord.
Don't forget to vote.
Don't forget to vote on the Discord. We'll report back on the Discord with my inevitable fail.